I go first? Okay. Morning, everyone. My name is Donato Napoletano. I've been with Saipem for 24 years now, mostly spent with the Sonsub, so dealing in projects ranging from umbilical installation to trenching to ROV operations, and now drones. This is a new technology. Since 2019, I'm managing the Njord ROV and the UID services contract with Equinor. So the topic of this presentation today. That's it for me.
Good morning, Cristian Nevoso. Nice to meet you. I'm the solution manager for subsea drone and ROV in Sonsub. I've been working for Saipem since 2007, so even in my case, it's pretty long time. We started working with Donato when I started 18 years ago with trenching, and then I passed through field engineering, project management for a long time, for then moving to the the new world of the subsea drones since 2017 when we started. I'm based in Venice too. I'm an electronic engineer with a subsea robotics background. And I spent almost 5 years in Brazil during the last years for dealing with the development of the Hydrone platform there with the collaboration of local Brazilian entities, in which we had the possibility to put some specific artificial intelligence on our vehicles. Then I just came back last year in Venice. Thank you all for being here today. I think that we can start with the presentation. I don't know if...
Do you want me to share, Cristian? I'll share it. Okay, let me know if you can see it.
Yeah, I can see it.
Okay, I'll then start it.
Let's see if it will
It's
work.
slow. Yeah.
Okay.
I leave to you to start, Cristian.
Yes, as we said, the main agenda of today, it will be a general overview of the Hydrone platform vehicles, for then giving you just a brief introduction about how and why we developed this new set of subsea drones, for then entering more in details in the Hydrone-R vehicle specifically and Njord deployment and project. Just a very brief introduction about Saipem and where we are. I mean, we mentioned the fact that both of us are working in Sonsub, which is a division in Saipem. Saipem is a pretty big company. We are based in Venice in a pretty small, I would say, office, but it would be very focalized on R&D and robotics and industrialized solution. So in our office, we concentrate the main effort on developing ROV solution, a subsea drone solution, pipeline repair systems, subsea factory solution. I mean, we are really concentrating on new technologies, mainly for supporting Saipem activities, but even for expanding new technologies to the oil and gas energy, I would say energies industry. Going ahead. Okay, let's start with the Hydrone platform overview. So, as I said, back in 2016, we start working on a new generation of subsea drone for changing our way to approach to subsea activities, especially for inspection and intervention campaigns. So we start developing a family of vehicles called Hydrone, that are the main characteristic is the fact of not having not having need to have a support vessel always on top of the vehicle, but they can remain subsea resident for a few months, being controlled from a remote control station. So this was the main novelty that we try to introduce in these new vehicles, which differs from standard ROV or AUV for this main reason. Then, meanwhile, we developed the platform. We also introduced a lot of new technologies, artificial intelligence capabilities, a new set of sensor for, having a more quality data, reliable information, and try to expand the way on how we used to perform IMR activities. So all the vehicles are designed for 30,000 meter water depth. They are all full electric vehicles. There are a set of components that are shared between the vehicles. I mean, it's a platform and even functionalities and algorithms that has been developed so far. Everything has been developed internally in Saipem Sonsub with specialized support for specific cases, but the main core and the main activities has been performed internally. The first vehicle that has been developed starting from 2016, 2017, it was the Hydrone-R that has been completed in 2019. This is a light intervention class subsea drone. So it is an hybrid ROV AUV vehicle, so it can work both tethered and untethered. It has light manipulation capability. And it can remain, as we said, resident configuration. We will enter more in detail about Hydrone-R, so probably that doesn't make sense to spend too much time on that now. Flatfish is instead a full AUV vehicle, which differently from the conventional AUV. It can even control the 6 degrees of freedom, so allowing station keeping, structure inspection, riser inspection. It can even navigate, apart from horizontal lane, it can even navigate vertically for vertical structure like riser or mooring line. It can navigate for longer range since its hydrodynamic shape, and it has a very good artificial intelligence embedded to allow to recognize obstacle or defect on structure. There are many things that has been developed on this vehicle. The last that we just completed is the Hydrone W. The Hydrone W is more a Work Class ROV type of vehicle, so it's still a drone that can remain underwater for months, as for the other vehicle in the family. It has been completed a few months ago. We are just completing the commissioning this month. We will then discuss a bit more even about this vehicle. Moving ahead. So, why we started to work on this new family of subsea drone? Mainly it was for reducing the costs, reducing the risk of operation, and reducing the CO2 emission, while improving the way of operating. So the main target of this vehicle were, in fact, to reduce as much as possible the offshore support while we are operating. So as soon as we deploy the vehicle in a subsea garage, subsea resident configuration, in the case of the Njord, it was a subsea docking station, then you can, through the remote control station, control it, supervise on it, or pilot it. So this was one of the main key change that we try to introduce with this new technology, and we will show you that the results were very good so far, and we are aiming to arriving to the full change of the way of performing IMR campaign soon. As we said, the vehicle can remain underwater for long time. We achieved 8 months in a row, controlled by a remote control station that can be in the same area or wherever in the world. So this is obviously a very good improvement. And even in terms of quality and amount of data that you can acquire with these new drones, having them always available for inspection, of course, you can get much more information than a typical offshore campaign in which you are like cost driven by the cost of the vessel. So in this case, as soon as you complete your commissioning and the vehicle is ready to start, you can launch mission or you can just pilot the vehicle or whatever you want for the time you are there resident and collect a lot of information. And these obviously can give more value to the operation. Please stop me if you have any question or any specific doubts. Then let's go to more detailed description of the Hydrone-R. I mean, as we said, is an hybrid AUV ROV vehicle, so it has light intervention capability through a manipulator and a grabber. It can work tethered. It has a TMS integrated in the body of the vehicle, which allow to manage the tether length while it is navigating. With the tether connected to the subsea docking station. The vehicle is battery fitted, so it can travel for a few kilometers and typically for a shift of 12 to 14 hours in terms of autonomy. It can remain subsea resident for a few months. As we said, it was already tested in this configuration, and we will see then in Njord what we achieved already. Currently, the Hydrone-R is remotely controlled from a remote control station. It can even be controlled, of course, from a vessel if you decide to use it as a more conventional vehicles. I mean, there is even this flexibility of using it as a launch recovery from a vessel or in a resident configuration. It's a flexible platform in the sense that we have a set of payload sensor permanently embedded on board the vehicle, like stereo camera for allowing 3D reconstruction, both in front and down camera. We have a set of sonar that help the pilot or the vehicle to navigate and to use the collision avoidance functionality. We have also an imaging sonar. We also have a laser for getting more inside structure inspection. Then, apart this, we also have the possibility to embed an external payload skid in which we can embed additional payload sensor. The case, for example, of the CP skid is the one that we developed in the platform, in the Hydrone platform, in which, for example, we introduced the contactless CP probe for cathodic protection monitoring without touching the structure, and can even be used for tortooling. For example, we have also a skid for tortooling developed for Njord. We can actually, is an expanding skid in which we can like introduce the sensor or the capability that you want, and then temporarily connect to the vehicle for performing the operation. Donato, I don't know if you want to add something on this.
No, the skid that we are utilizing on Njord, yeah, that's very good, Christian. Just to be more specific on what we have on Njord, we have an underslung skid that can host CP probe, tortooling, electric, and water jetting. Yeah, this is what contractually we were supposed to deliver to Equinor.
Okay. Going ahead. Hydrone-W instead is the second vehicle that is supposed to be deployed in Njord. Currently, I mean, we didn't touch the contractual aspect of the Njord project. Probably Donato will touch it more in detail later, but we signed this long-term service contract with Equinor in 2019 for 10 years service contract, in which we foreseen the deployment of the Hydrone-R and the Hydrone-W in the same field. So we started with the Hydrone-R that was already ready, and then the Hydrone-W was developed meanwhile and is now ready for being deployed there in Njord. There are some discussion ongoing with the client for understanding the best moment or the best way to use both of the vehicle there in Njord. The Hydrone-W is a full electric Work Class ROV style. It's a subsea drone that is instead power fed from external power source instead of having batteries, even because in this case the power required is pretty higher for having, the EV duty works completed, performed properly. It's a full electric even in terms of manipulation, so there is no hydraulics on board, apart for specific auxiliary tooling that we could want to connect, but it's 100% fully electric. It's even in this case has the capability to remain resident configuration for a long time and being controlled from a remote control station. Currently, we are completing the commissioning of the vehicle. We will see later the roadmap with some dates. The vehicle is currently in Trieste for complete the commissioning test and the final acceptance test from Equinor. Moving ahead. Okay. Since we discussed about this new technology and why we developed and all the novelty that we tried to introduce, of course, one of the main steps was the testing and the qualification activity. I mean, as soon as we introduce new technology in the oil and gas industry or energy industry, of course, we want to have something reliable and very well qualified. So we passed through a very long qualification process that last many months for all the vehicles and was completed in our facility in Trieste. I mean, this is just a very brief overview of the Trieste playground. Go next, please. Yeah, here is so actually close to Venice, like 1.5 hours by car. We have Saipem has a yard there for general logistics and operation. In this yard, we have a space that has also access to a jetty and to the water. So this is the area where we used to test subsea solution in Sonsab and where we develop a small what we call playground, in which we deployed a few subsea structure in order to replicate a kind of small subsea field. There are two main areas in the facility. Go next, Donato. One is more close to the jetty.
Next, this one.
Okay. So I mean, as I said, there are two main areas, one more close to the jetty, and the other one is in the open sea, I would say. It's not very far from the coast. It's like 1 kilometer from the jetty, and where we installed a few pipeline, few structure, few cases for trying to train the vehicle, for trying to inspect the things properly, and for qualify all the functionality. If you go next, we can see even the detail of what we already installed. Okay.
No, was the previous? Oh no, there is no slide for the detail.
Okay, probably we didn't introduce that.
Yeah.
I don't know if there is any questions so far with the general overview of the Hydrone platform and qualification and testing facilities. Otherwise, we can just move ahead with the Njord project.
Yeah, this is Eirik again. You talked about that you implemented artificial intelligence into this. Is that something you could talk a bit more about?
Yes, sure. Actually, I mean, mainly for Hydrone-R and Flatfish, we developed some specific functionalities for helping them to properly navigate or recognize feature or recognize anomalies while they are performing autonomous inspection, or even in case of, reduce the risk of collision while we are navigating even in ROV. So in this case, a layer of artificial intelligence has been developed internally in Saipem. These, through the sensors that are embedded, are able to, improve the way of how the vehicle can navigate autonomously. Just, for example, looking at the obstacle avoidance feature And I mean, actually, the vehicle, while is navigating in ROV and there is an obstacle in front of him, he can stop, understand if there is space on one side or another to replan the path for overcome the obstacle, for then restore the original path and continue with this pipeline inspection mission, for example. I mean, this is one of the things that we developed. We also developed the capability to recognize specific feature underwater for understanding if there are any anomalies on such feature. For example, one of those is the anodes recognition. So you can imagine that while we are performing a pipeline inspection, every time the vehicle encounter an anodes, it can stop and take specific picture or take some specific reaction behavior for getting more information and bring back. In case of depletion of the anodes, you can even raise like a marker and you say, okay, in this point, I found something wrong with the anodes. There are also other feature recognition capability for fix the position of the vehicle or for, improve the relative navigation around the structure. I mean, all these new functionality has been developed. I mean, as you can imagine, since it's something very new for this technology, it's always in a step of in a phase of improvements, but we are already in a good shape for using them offshore.
Okay, thanks.
Okay, let's start with the Njord overview. Donato, please.
Yeah, if no other question, I'll move to the Njord project. So this is just a slide to show what the field looks like. We're operating in 330-meter water depth, good visibility, low current environment. Of course, it's the North Sea, not the Norwegian continental shelf, so harsh weather and sea states. And it's an icon complex in subsea layout, meaning that there are numerous subsea tiebacks to other fields. It's a congested spread mooring and dynamic risers, and there are a lot of abandoned cabling and matrices. So it's quite. This gives a good impression on how complicated it can be flying a vehicle autonomously in such an environment. The operational architecture is this is just to present what is the difference between a standard ROV service, let's say, and what we have deployed on Njord for Equinor. So typically on a rig or on a platform, there is one work ROV or two, depending on deck space and an observation ROV. We have partially that, meaning that the long-term scenario will be to have the work ROV covered by Hydrone-W as presented earlier. At the moment, we have deployed the HIS design support ROV while waiting for the mobilization of the Hydrone-W, the electric system. And instead of the observation ROV, we have the Hydrone-R. So it's a system that is deployed from the rig but stays subsea for a few months. So there is basically a docking station connected to the rig with fiber and power, where the vehicle can stay, recharge its batteries, and download the data from the missions. As already anticipated, the vehicle can work either in tethered mode. We have actually 300-meter tether installed on the Hydrone-R TMS, but it can also operate and communicate optically in a range that can go up to 50 meters from the antenna, from the modem, or acoustically. So basically with communicating through the iPop of the rig. This image is also showing that there is, of course, a link from the platform to the onshore control room. We have office and control room in Forus, Stavanger. You're welcome to visit. By the way, if you pass by. And yeah, the video on the right side is just showing one of the docking of the system onto the Equinor provided subsea charging station. So The docking station is basically to park the vehicle, to recharge the batteries, and to download the data. Plenty fishes. That can be also a problem. We have learned that operating on Njord that they can have impact on the optical and acoustic communication, but it's something that we are learning to manage. Okay, then we have inserted this video.
This is a short video of a streaming that has been organized last year while the vehicle was performing subsea intervention and subsea activities. I think it was good to see, the vehicle working real time there while we were performing the activities, and it gave a flavor of what we can achieve there.
Exactly. One year ago at the UTC in Bergen. So exactly 1 year ago that was a live stream there. Okay, next, just some highlight on the project schedule so far. As already anticipated by Christian, the contract was awarded in 2019. Then the rig was delayed by a couple of years because of the pandemic. In 2022, we did the company acceptance test of the Hydrone-R, but at the time was still in Trieste, was not mobilized. And we did the first, we started the operations in parallel with the rig production activities with the work ROV that is presently installed on the platform. In 2023, we performed the first mobilization and dive of the Hydrone-R, and we completed and started to operate the onshore control room in Forus. 2024 was the second dive. So in between the dives, the system, of course, being resident, cannot be maintained, so it has to come to surface and be shipped onshore for the maintenance. So 2024 was dive number 2. 2025 we are about to start dive number 3 for Hydrone-R. Should be tomorrow or the day after, having completed the second planned maintenance. And we are, as already anticipated by Christian, we are in a discussion with the client to agree on the mobilization of Hydrone-W that needs to be swapped with the other RV that at the moment is on the platform. I'm gonna add, this is just a slide to present some highlight on the first dive. It lasted 165 days continuously. Was quite impressive, and to me the most important thing to highlight is that this could be achieved mostly because we performed extensive testing in Italy in our playground prior to going offshore. But still, even after so many hours of testing, was the first time that the vehicle was deployed to depth in the environment where it is operating. So we were very, very pleased about reaching this big number of days. And it was even more on the second dive that was completed last year. We achieved 240 days, almost 8 months continuous operation. 0 days wasted for waiting on weather, of course, because it's a resident. We did a period 11 days in which we counted over 2024, 11 days in which the work ROV was waiting on weather, so it was not possible to deploy it, but the Hydrone-R was able to complete, to carry on with the Njord inspections program because of course it was ready in subsea. We did 30 days more with more or less without ROV support. So basically, there was a period in which the platform underwent a revision stop. So there was no ROV personnel on board the platform. There was no ROV deployed, and we had only Hydrone-R supporting the rig operations and piloted from remote for a period that lasted about a month. More than 5,700 hours continuous dive and more than 10,000 hours of offshore saved with remote operations. A few tangible achievements, as already said and reiterated, the successful resident deployment for the world's first contract of such type, risk and cost reduction, mostly driven by the subsea residency and the remote control. We are part of a wider project of electrification of the Njord Field, having delivered electrical vehicles, fully remotely operated. We have performed mostly last year during the second dive hundreds of autonomous missions. For the time being, we are taking basically a step-by-step approach. We increase the complexity as we go. So last year was starting to perform autonomous missions, but in the range of the work ROV tether, so to take a risk in a controlled manner, while the target for the next dive, the one that is about to start, will be to go beyond and starting to explore and push more on the delivery of the autonomous missions. We did also over the years achieved a couple of awards. In 2021, it was the OTC Spotlight Award in Houston, and in 2024, the UTC Award in Bergen for the technology. Additionally, a few key performance factors. So far, we have had 0 incidents. The reliability of Hydrone-R has been excellent. I think we have overall just up in the first and second dive, we have only 13 hours breakdown. There was an event in which we lost communication with the vehicle, and for 13 hours we had engineers from Italy trying to connect to the vehicle and reboot the control system. But apart from that, has been always operational. Overall, we have achieved, as I said, 405 days subsea in between the 2 dives, and probably this is not too much updated, but we are in excess of 450 days in which the vehicle has been operated from shore. It's basically mostly operated from the control room in Forus. Okay, then to conclude, just a few more details on what we can conclude has been the experience so far. Overall, it's been very, very positive, mainly because of safety results and the reliability of the system. It's been also good the path so far with Equinor, with the client, because they've been always cooperating. It's been a real teamwork approach that is always pleasant to do so. We have demonstrated the savings driven by the residency and remote control, exceeded the expectation on subsea residency. Myself, I wouldn't have believed that the system would have stayed so far 8 months subsea without any trouble. So even the people working in the team, like myself, was really happy about that. Then we have over the second dive, we have pushed the limits, the system to the limits, because we at the beginning, first dive was like again in line with the step-by-step approach. We didn't push the system too much. It spent some time during. It was not basically introduced directly to the operations, but during the second dive, we basically flew the system every day. And it took part to the real operations more than we did during the previous dive. So it's even getting more confidence as we go from the people and from the client. We have learned a lot also on the field, because of course we are in different different environments from the testing facilities. For example, we have implemented acoustic communication environmental adaptations that was not possible to do in Trieste because we had shallow water. So we have learned how to communicate with the vehicle on the field. We have performed like 400 hours AUV missions, still connected with the tether, but fully in autonomous mode. We did also demonstrate on a few occasions full tetherless AUV inspections. We did some Christmas tree inspection in autonomous mode and a survey grid. We did learn a lot on the recovery of the vehicle when it was sent to the maintenance. As you can see from the picture, in some component like the manipulator, the amount of corrosion, marine growth has been excessive. But we have this has been a good learning because the system generally has been designed by us and it's designed to be subsea resident. But there are third-party commercial items like the manipulators that are not sold to be resident. So there has been a lot of work, particularly during the last maintenance, to improve the third-party equipment subsea residency performances. So we expect that this will be an improvement over the future dives. We have also learned by doing what we can do with the system. For example, we have, I can show Bertil in the next slide, something that we have thought during the operation was to connect basically the Hydrone-R to the Work ROV, rather than connect the tether of the Hydrone-R to the SDS, that is the subsea docking station. This way, basically, we almost doubled up the length of tethered coverage. So this way, we can further reduce the need of a vessel to perform such some sort of inspections, because we can actually go with the system in tandem configuration up to 500 meters from the platform, and this should bring significant savings for Equinor. This is something that has been tested already, not to 500 meters, but during this upcoming third dive will be hopefully proven. This is something that we are working on. Okay, then it's, as I said, we are about to start the third dive. Focus will be very much on keep learning and keep developing autonomous missions. We will start once again with the field adaptation and familiarization, because, for example, the issue of the fishes interacting with the communication of the vehicle still needs to be fine-tuned. We will deliver most likely further Christmas tree inspections in AUV mode. We want to also demonstrate the capability of the vehicle to search a pipeline and follow it in an autonomous mode. There is actually the export line connecting the Njord A to Njord Bravo. That is something that we want to do and inspect in autonomous mode. We also have to fine-tune the capability of the vehicle to auto-dock and auto-undock from the subsea docking station. And something that has caught the attention of the client is also a scope that consists on inspecting an Arctic coral reef that's like 1 kilometer away from Njord, as shown in the picture. The client is asked to perform an autonomous mission where we will fly to the location, perform a survey of the area, and come back and provide information on the status of the Arctic coral formation. So this is something that is, if it will be successful, it will be easy to repeat from time to time to monitor the environmental situation of the coral. And lastly, we have already did some activity. We've already done, some activity on the leak detection, and most likely we'll carry on that one. Basically, acquiring, teaching the vehicle to recognize fluid sensors, mostly sonars, leaks, and basically being response and means responsive and communicate immediately in case of finding any leak. I think I have finished. So yes, this was the last one. We didn't go too much into details, but if you have something that you would like to know more about what we are doing for Equinor and on your platform, me and Christian can hopefully answer your questions. Stop presenting.
Yeah, I have one question about the distance. How far can it go away from the docking station?
How far?
Yeah. Or is it like time or? Yeah, if you're doing the pipeline inspection, I guess that's like limitation how far.
From Njord A to Njord Bravo, it's I think it's less than 2 kilometers, but I think the acoustic communication, we in theory can work up to 3 kilometers in that conditions. We need, of course, to demonstrate that we can go that far. Christian, correct me if I'm wrong. I think that we can even go further than 3 kilometers, but then we will not have any communication, right?
Yes, I mean, indeed.
Acoustic.
I think that the question is more related to how much autonomy the vehicle can deal without having the recharge of the batteries. So the vehicle can travel about 10, 12 kilometers maximum. Obviously, it would be in this phase, we are trying, to always have an eye of what the vehicle is doing through acoustic communication. So, I mean, what Donato was mentioning is the fact that having an acoustic beacon talking with the vehicle, so at least to monitor its position of what it's doing, not obviously of piloting, because through acoustic is not possible. I mean, the communication is not fast enough for piloting, but at least to monitor what it's doing, it's something that we are trying to keep, But generally speaking, with the increasing of maturation of the technology, we expect to, even launch mission in which we don't know what the vehicle is doing for a few hours, for then waiting for it's coming back to download the data and post-process the inspection data. And this is in this range of 10 to 12 kilometers maximum. It depends on the type of task, or it depends of what the vehicle needs to do, how many sensors we need to switch on, because I mean, since it's a vehicle battery fitted, you can imagine that if you have many sensors switched on because you want to have a pipeline inspection, CP, and other things in parallel, of course, this could be impacted, or even if the environment is challenging. So Njord, in this case, is not a very big sea current, close to the seabed at least. So these allow us to do this. Obviously, if you are in a more harsh environment, then with higher sea current, this could be affected.
Okay.
You said that there was a lot of fish as well that could impact the communication. So that would impact the sonic communication then. So what do you do to improve that, or would that also have an impact on the fish as well?
Well, we don't believe there is any impact on the fish itself, even because actually the vehicle is moving pretty slow. I mean, it's typical operation that we can also do with ROV, and even with ROV, we used to have such environment full of fish. So I mean, in these terms, we are not worried. For what concerns instead the communication with the vehicle and the sonar behavior, I mean, what we experience, the fact that we need to really fine-tune a bit more, the fact of, encounter a bunch of fishes that can appear as an obstacle, as you can imagine. One of the things that we are improving on field, I mean, and this is very good because we can improve the software and improve the parameters while we are there, and then, testing every time and improving the things. is the fact to introduce like a logic in which as soon as there is an obstacle in front of you, and it's even moving obstacle, it's something that it's not a real obstacle for you, but it's more associated to a big fish or a bunch of fish, you know. And this is something that it's still under fine-tuning. That is one of the things. And the other one is instead related to the optical communication that Donato was mentioning, because the vehicle, probably we mentioned before, it can be controlled via tether, so physical tether, as an ROV does, but also through optical communication. So there is an optical modem installed on top of the vehicle. There is another optical modem installed on the subsea docking station. And through this optical link, we can pilot the vehicle in a range that is between 50, 60 meters, so not very long, but at least, having the same performances that you can have with a tether connected. So in this case, for example, as you can imagine, if you place an optical modem close to a structure, for example, you can go there probably in autonomous mode. Then as soon as you arrive in the range of the optical modem, like take this link, optical link, and then pilot to the vehicle to perform some intervention. One of the things that we are still working on, and it's probably something that it will come more in the future, is the autonomous intervention capability. So at the moment, the autonomous part is related to the inspection, so navigation and inspection, while for intervention and manipulation, we are still need to have the pilot connected from remote to through a tether or through an optical communication.
Excellent, thank you. So, any other questions? I think there are no more questions online, but thank you very much for a very interesting presentation. It's a bit outside of the normal stuff that the North Sea Well Productivity Network is diving into, but this is really good. So really appreciate your work on presentation there. So thank you very much. And then we will have the presentation available as a video as well for people that haven't been able to see the presentation, and we will share this. So thank you very much again. And then
thank you.
You're welcome. Thank you for your time.
Thank you.
Okay,
Have a good day.
Okay,
Thank
bye.
you.
Bye. 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 Have a good day.
Bye.